What is good, guys and girls of YouTube? It's your boy Justin Omoe here with a quick video for you guys and girls. Today I'm gonna give you a quick talk into input, output, and some stuff that has to do with it. With easy speaking, an input is something that you put into. So let's say like this little thingamajiggy right here, the audio interface. This will allow you to have two inputs, meaning you could plug something in there for it to record into or to go into. You could put in a guitar wire, you could put in a microphone with the XLR port, you could even put in a something else that's already processing through, and I'll go over that as well. And the output is something that it goes out of. But there's two TSR ports right here. This is for left and right, 1 and 2. We also have 4 RCA ports, which is 1 and 2. So these two right here correspond with these two. And then we have two separate ones, 3 and 4. What the output will do will allow us to be able to hear the sounds that's coming out, as well as we could send these sounds to go into another device that could be rerouted or sent back into the same audio interface. So if you're wondering why this interface is called a Scarlett 2i4, just know there is 2 inputs and 4 outputs here. That was pretty easy. Wow! But there's some things that go into the input and output that we have to also know about, because this is something that is really critical when it comes to recording or playback. Also forgot to mention, this is not the only thing that has inputs and outputs. Things such as your headphones, your microphones, this has input and output as well. As you see, this right here is the thing that you will use to create the input sound, which will be going through a USB microphone or USB slot. In this case, we're using the USB microphone, the Samson G-Track. And this as well has an output spot right here. Notice the little headphone icon and the little hole for you to listen to your music. Not all microphones have an output. So for example, this Samson CO1 studio condenser microphone, it's an XLR one, not like the USB one we just seen, but this only has an input, meaning you could speak into the microphone, which has something called a diaphragm. You know, I might as well teach y'all that. But what happens is when you speak into it, it'll capture the vibrations because it's like a little plasticish ring thingy. But what happens is that when you speak into the microphone, it'll, you know, vibrate that diaphragm, and then it will be converted inside of here to be captured. So if I open up this thingamajiggy, give me a second. Okay, I tried to open it, but I don't know if you can see this, but this key got bent the hell up. So, you know, I'll just Google image it. But when you do speak into the microphone, it does the vibration, but then it gets converted from analog, which is your speaking, into digital. This is known as transducing, when you're sending a sound signal to something else and then it goes into another thingamajiggy. But yes, so what's happening is it's converting from analog, which is a speaking, to digital, which is 1s and 0s. Then it goes into the XLR cable, and that does the transferring, goes into the audio interface, and that will allow it to go into the software. And then from the software, it goes out back into the audio interface, depending if you set the output to the audio interface, by the way. And then that will be transduced into the speaker. The speaker gives out, you know, sounds back so you can hear it, as well as your headphones. Of course, it will not be the same as you hear it because it goes through so many DAC, digital analog conversions. And that comes from what we know as sample rate and bit depth. So if you heard the term before, 16-bit, 44.1 kilohertz, that's basically the bit depth and the sample rate. Many of you guys and girls might find it confusing, but don't worry, I got the key. I'm gonna make it easy for you guys and girls to understand. Sample rate is the left and right, okay? So it's how many points it records. There's many different sample rates from 44.1, like I said, which is CD recording quality, which is basically I could hear myself. Along with 44.1, they also have 48 kilohertz, 48,000 samples, 96 kilohertz, sometimes 82, and so forth. Those are basically all the points that it takes to capture our sound. Now, if you notice, digital is all like squarish shapes and point by points. A regular analog voice would be all, you know, wavy and smooth and realistic, where digital will all be points. So it's like, you know, one point here, the other point here, and then there's third point and a fourth point, and then what it does is connect the dots to make these sound. Of course, the more the merrier, but 44.1 is ideal and it's okay to use. But if you want to record in a higher resolution, you know, go ahead. It'll just take up more space and some, you know, memory RAM. But, you know, if you want higher quality, you got to pay the price or pay the CPU requirements. Now that's what sample rate is, the dots. Now there's the bit depth, which is the up and down. This is basically the volume for the sound. So 16-bit, it sounds kind of like, you know, oh, that's kind of retro, isn't it? 16-bit, you know, like 8-bit games. Don't think that, because what 16-bit is basically a amount of volume. Volume, yes, going up and down. 16-bit is actually 2 to the power of 16, which is like a lot. You know, I'm acting like I'm doing the Indian multiplication, but it's somewhere around like 64,000 points or maybe more, which is a lot. And that's why it is normal for CD recording quality. But yes, the bit depth is the one that help connect the dots. It's the one that whoop, 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 whoop. It gives the ups and down to the points that are just horizontally there. The more bit depth, the more of a resolution it'll be able to capture. So if you record in 16-bit, it'll be like, you know, still there. But if you record in 24, it'll have more of a dimension to be able to record with in terms of volume, up and down. There's 16-bit, there's 24-bit, there's 32-bit float, and it's like, wow, that's a lot of stuff. Many of the USB microphones I've seen, they're usually around 16-bit recording, and yeah. As for XLR microphones, it depends on the audio interface to be able to give you the amount of resolution. Oh, the higher the better. Well, you don't really have to worry about it, because in the end, you'll still be able to hear yourself even with 16-bit. Back to the USB microphone, this is a 16-bit, you know, capturing device. And if you've seen my video on which microphone should I buy, you'll see that I did a test with this microphone as well as some other microphones. I don't want to spoil it. And if you haven't seen that video, go ahead and click the little I button right there, and I'll link you to it so you'll be able to see that and know that it will not really, you know, matter in the end. Spoiler alert. Last but not least, I'm gonna talk about one more thing before I go. I'm actually surprised that I'm still talking. It's a long video, but you know, I gotta do what I gotta do. One more thing, buffer rate samples. What is buffer rate samples? Or the buffer sample rate. Yeah, the buffer sample rate. This is basically something that has to do within the program of your computer itself, as well as some influence within the audio interface that you're using, aka the sound card. The usual setting is around 512 samples, meaning every 512 samples per like millisecond. Some of you guys and girls might have a latency, and that's because of all the drivers that you have to connect within your computer. That's why I use it. You know, the sound has to go into this driver, and then it goes to there, and then it comes back, and such and such. That takes a lot of time, especially with direct drivers. However, with ASIO drivers, it links directly, so it's a, you know, cleaner, cut to the chase thing. That's why if you set yourself to ASIO, you'll notice the thing is not delaying the sounds. It goes like right immediately, and you see the waveform as it plays. If you raise the buffer sample rate to something like, you know, 1024 or 2000, whatever 24 times 2 is, 48, you'll notice that the sound will be played nicely, but it'll look like more of a latency and a delay going on in your system. That's because it takes more time to you know, intake all of those samples before playing it back. If you lower it, say you go into something like lower than 512, I guess, I don't know, half of 512, you'll notice that it plays back even cleaner, even faster than you noticed, but it might cause glitchy sounds. The reason is because it's taking, less steps. So, a little hamster thing. But with those little steps, it takes, less samples. Something that will be called underruns will occur. And the underruns is those little clicky, weird, glitchy sounds. That's because you didn't have enough time to process all these sounds, and therefore it'll give you a little like those weird awkward sounds. But yes, you mainly want to keep that in the middle to ensure that you're getting the great amount of sounds without causing those glitches. It's really something that depends on your computer, like specs, as well as your audio interface, the audio card. So yes, that's it. Hopefully you guys and girls intook a lot of things, terminology, because this is like something that you really have to learn when it comes to recording and making sure that everything sounds right and such. Last thing, I did not mention this, but you can have as many inputs and outputs as you like within your digital audio workstation. You'll notice within FL Studio's mixer, each insert you could have an input and you could also have an output. So, you could set the output of a certain group to be like, say drums. Let's group the drums and route it all into one insert, and then have that output go into, or output into, someone else's headphones. That's possible, and it is possible. It's done to help mixes and make people be able to hear certain sounds while you hear everything as a whole within a studio. And likewise, you could have multiple inputs to ensure different recordings at the same time. That's how, that's how you could have drum sets recording every different sound. So yes, with that being said, hopefully you guys and girls like the video, like it, give it a thumbs up. Be sure to subscribe if you want to stick around with your boy. I know the phone's on, but it's annoying. But yes, my name is Justin Omoe, and with that being said, peace. Video cut off.